The introduction of the new Octavia enables Skoda to enter a different category of the market with a car which is bigger, more stylish and technically advanced. It has an individual design and offers excellent levels of equipment and high standards of build quality and safety. The Octavia is produced in the Czech Republic at a new factory in Mladá Boleslav. The factory has been designed to be environmentally friendly and utilizes the latest materials and assembly techniques. This video gives an insight into the new car, and although it's designed primarily for technicians, it should be useful to all people who work in the dealership. The self-study book 15 provides further information and should be studied in addition to viewing this video. In-depth technical information and repair details are in the repair manuals. The tape's in 5 sections. Section 1 gives a brief overview of the car. Section 2 covers the engines. Section 3 looks at the transmission and running gear. Section 4 explains the layout of the electrics and the heating and ventilation system. And Section 5 looks at some of the safety aspects and details on how to remove an interior door panel. To help locate items when reviewing them at a later date, there's a counter in the corner of the screen and an index on the video cover. We hope you find the video interesting and helpful. Section 1. Vehicle Overview. The Octavia, measuring just over 4.5 meters in length, is a roomy hatchback with levels of equipment which would have been unthinkable only a few years ago. Many features have never been available on a Skoda before, and depending upon the model include galvanized body to resist corrosion, bonded front and rear windscreens for enhanced rigidity, twin airbags, pyrotechnic front seatbelt pretensioners, side impact protection beams and foam inserts, power steering, ABS brakes with rear discs standard on vehicles with higher engine outputs, McPherson strut front suspension with wishbones, torsion beam rear axle with passive steering, 14 or 15-inch road wheels depending upon the model, H4 headlights with integrated fog lights, electrically operated and heated mirrors, engine immobilizer, and a brand new heating and ventilation system with pollen filter and air recirculation function. Other new features include a CAN network central locking system with optional remote control and a remotely operated fuel filler flap. 5-speed manual transmission is standard with the option of a 4-speed automatic for cars with the 2 most powerful petrol engines. The Octavia will be available in LX, GLX and SLX versions, initially with a choice of 5 engines, 3 petrol and 2 diesels. The 2 1.6-litre petrol engines have an output of 55 kilowatts and 74 kilowatts respectively, and the top-of-the-range 1.8-litre 5-valve per-cylinder engine develops 92 kilowatts. The 2 1.9-litre diesels use direct injection with full electronic diesel control. The turbocharged TDI produces 66 kilowatts of power, and the naturally aspirated SDI engine, to be introduced a little later, develops 50 kilowatts. The 5 engines utilize 2 types of 5-speed gearbox and 1 automatic transmission. The 4-speed automatic, featuring a dynamic shift program, can be specified with either the 1.8-litre or the 1.6-litre 74 kilowatt petrol engines. The O2K manual gearbox is fitted with the 1.6 litre petrol engines and the SDI diesel. The O2J gearbox accompanies the 1.8 litre petrol and the TDI diesel. All transmissions are further developments of well-proven units from the Volkswagen Group. A 50 kilowatt multi-point fuel-injected 1.4 litre version of the renowned Skoda engine will be introduced later. Section 2. Engines. The 1.6 litre 55 kilowatt engine should already be familiar to you, as it's basically the same as that available for the Felicia. The engine was the subject of video number 9. However, one component which is new, this applies to all the other petrol engines incidentally, is the potential-free lambda sensor. The sensor's earth connection is now made via a cable and the engine control unit. This, together with other changes within the control unit, have been designed to improve the self-diagnosis capabilities by altering the sensor's operating voltage range. Instead of the earth voltage being 0, it's set to a small voltage, in this example 700 millivolts. This increases the sensor's normal regulating range of 0 to 1000 millivolts to between 700 and 1700 millivolts. There's more information on this subject and how it affects fault diagnosis in the self-study book. Other than the 55 kilowatt engine we've already mentioned and the forthcoming 1.4 litre, the remaining engines are all brand new for Skoda. Before considering each one in more detail, though, here are some features which are common to them all. Firstly, they all have overhead camshaft with hydraulic self-adjusting tappets. The camshaft is driven by a tooth belt, which also drives the water pump. The long life belt is maintenance-free. If removing it for any reason, however, then always consult the repair manual before starting work, as the techniques for removal and refitting vary slightly depending upon the engine type. The oil pump of the lubrication circuit is chain-driven from the crankshaft, and it's fitted with a spring-loaded tensioner. To reduce weight and increase heat dissipation, most engines have aluminium oil sumps. And to improve engine and transmission rigidity, they're bolted to the transmission. It's silicon sealer, not a conventional gasket, which forms the joint between the sump and crankcase. All engines incorporate lightweight valve gear. This is achieved by using thinner valve stems and the fitting of single-coil valve springs, together with a reduction in the width of the camshaft lobes and their followers. In addition to weight saving, less effort is required to drive the camshaft. 1.6 litre 74 kilowatt engine. The 1.6 74 kilowatt engine, with an engine code of AEH, is an all-aluminium unit. The cylinders are formed by steel liners, which are then bored out to size. Unlike the wet liners of the well-known 1.3 litre engine, these dry liners are not removable. The cross-flow cylinder head features a composite plastic inlet manifold with variable length intake paths. A long inlet path for generating good torque is utilised at lower revs, and a short route to produce maximum power is used at higher revs. To improve the smoothness of the idling, though, the air is also directed through the short route at idle. It's only when the throttle is opened and more torque is required that the manifold switches and the inlet air takes the longer route. At around 4,000 RPM, the manifold switches back, and the intake air is once again directed via the shorter path, allowing the engine to develop maximum power. The engine's crankcase breather system is a little different too. Instead of an external breather hose connecting the crankcase to the rocker cover, the fumes travel internally via a special passage. Engine management is performed by a CMOS-2 system, utilising one of the new generation of 80-pin control units. Due to the 80-pin 2-plug configuration, a new adapter, VAG 1598/22, is required for electrical testing. The engine is equipped with fully electronic distributorless ignition. The system consists of 2 ignition transformers housed in one assembly. Each transformer has 2 high-tension outputs, one supplying cylinders 1 and 4, and the other supplying cylinders 2 and 3. The transformer primary circuits are switched separately at the correct time by the engine control unit via a power end stage. When a transformer is triggered, 2 spark plugs fire simultaneously. The sparks occur in the cylinder on the compression stroke and in the cylinder on the exhaust stroke. As there is a combustible mixture in only one cylinder, the spark in the other has no function and is wasted. The spark in this cylinder is also smaller, as there is less energy required to jump the gap. The transformer for cylinders 2 and 3 is triggered 180 degrees of crankshaft rotation later. The ignition system is simple in operation, and other than replacing the spark plugs, it requires no maintenance. Because there isn't a distributor, the ignition system's hall sender is now behind the camshaft sprocket. The interrupter plate is also of a slightly different shape. The combined engine speed and cylinder 1 TDC reference sender is located here. It's of the inductive type and thus generates an AC signal. The intake air quantity is measured by an air mass meter, which uses a hot film type of sensor. 1.8 litre 92 kilowatt engine. The twin overhead camshaft 1.8 litre engine with distributorless ignition uses the Volkswagen Group's latest 5-valve technology. That's 3 inlet and 2 exhaust valves per cylinder. 5 valves enables the cylinders to be filled more effectively than with just 2 or 4 valves per cylinder. The result is improved combustion, which in turn improves the power output and helps to reduce exhaust emissions. The toothed belt drives the exhaust camshaft, and this in turn drives the inlet camshaft by a chain. This high-tech engine also features variable valve timing, which further assists in improving output, emissions and fuel consumption. The timing is regulated by a hydraulic piston within the chain's tensioner. A solenoid valve, controlled by the engine control unit, directs oil pressure at the correct time to a piston within the tensioner. This action causes the tensioner to move up, thereby turning the inlet camshaft in relation to the exhaust cam. The variable valve timing can be checked with the engine running using the VAG 1552 in the measuring value block function. You must, however, follow carefully the test procedure detailed in the repair manual to accurately check its function. If working on the cylinder head, note that it's important that the camshafts, chain and tensioner are only ever removed together, and only then after compressing the tensioner with a special tool, number MP1-232. Other than the 5-valve cylinder head, the engine's basic construction is similar to the other Octavia engines. 1.9 litre SDI and TDI diesel. The 50 kilowatt and 66 kilowatt diesel engines have a capacity of 1.9 litres. The S of SDI indicates normally aspirated, and the T of TDI denotes turbocharged. The DI stands for direct injection. Unlike the indirect injection diesel engine of the Felicia, these engines inject the fuel directly into the cylinders, the combustion chamber being formed in the top of the piston. This direct injection improves efficiency and reduces fuel consumption by as much as 15 to 20% in comparison with most indirect injection diesel engines. The engineers have also managed to tame the knock normally associated with direct injection, and thus have produced a highly efficient, powerful and relatively quiet diesel. Both engines produce lively performance and are incredibly frugal on fuel. Other than the different method of injection, the engine's operating principles and construction are similar to that of the diesel of the Felicia. One significant mechanical change is that the intermediate shaft which drove the oil and vacuum pumps has been deleted. The vacuum pump is now driven from the end of the camshaft, and the oil pump is chain-driven from the crankshaft like the petrol engines. A further innovation is that these new engines are totally electronically controlled. Just like the diesel of the Felicia, the injection pump creates the high fuel pressure and distributes it to each injector in turn. What's different is that the control aspects of fuel quantity and injection timing are now completely electronically controlled. In operation, the system, known as EDC, is similar to a petrol engine management system. An engine control unit receives input signals from a variety of sensors. The signals are compared against engine maps, and then output signals are calculated for the injection pump. These signals regulate electromechanical devices within the pump to adjust the fuel delivery quantity and the time at which the fuel is injected, depending upon the coolant temperature, the air intake volume and temperature, fuel temperature, engine speed, road speed, and accelerator position. Another interesting feature is that it's a fly-by-wire system. This means that there's no mechanical connection between the accelerator pedal and the engine. A potentiometer fitted to the pedal records its movement, and this signal, together with the other input signals, is analysed by the control unit. In the event of a problem, both engines have extensive self-diagnosis capabilities, which can be interrogated using the 1552 to help identify the fault area. To help you better understand the electronic control functions of the SDI and the TDI engines, they will be the subject of a future video. Other features of these engines include an aluminium rocker cover with non-replaceable long-life vulcanized rubber gasket, and an upright oil filter housing with a paper element. Replacing the element is less messy because the oil automatically drains into the sump when the cover is first unscrewed. Whether it be diesel or petrol, all engines use a new pendulum mounting system. The engine and transmission assembly is suspended at either end by two mountings, the one nearest the engine being hydraulic for improved dampening. This technique helps to reduce vibrations by allowing the assembly to swing, a bit like a pendulum, in response to the engine's normal torque movement. The swinging effect is restricted to a carefully calculated amount by a stabilizer under the vehicle. Section 3. Transmission and running gear. The O2K and O2J manual transmissions are developments of gearboxes already well proven from other models of the Volkswagen Group's range. The clutches are operated hydraulically and are supplied with fluid from a separate chamber within the brake reservoir. This ensures that there's always sufficient fluid left for the brakes in the event of a leak in the clutch circuit. The clutch assembly of the O2K gearbox is a little different from previous Skoda models. The clutch cover forms part of the flywheel, and the release mechanism is operated by a rod which passes through the centre of the gearbox input shaft. The clutch release bearing and operating arm are in the end of the gearbox. We explained earlier that the O2K gearbox is fitted to 3 different engines. Although it's the same type of gearbox, the gear ratios are specifically designed to suit each engine. To identify accurately the gearbox and the engine to which it's matched, each casing is stamped with a code. A table in the repair manual lists the gearbox codes together with the corresponding engine codes. To avoid fitting incorrect components, or even worse, the wrong transmission, always note the code before ordering replacement parts or checking specifications, etc. On the O2K gearbox, the gear shift is by a rod mechanism with integral damper weight. In contrast, the gear shift of the O2J gearbox is by 2 cables. One cable handles the gear selection, while the other moves the selector across the gate. To adjust the gear linkage of either gearbox, special setting jigs are required. These position the gear lever while the linkage is adjusted. Jig MP3-4001 is for the O2K gearbox, and MP3-4002 is for the O2J box. Incidentally, the O2J gearbox uses a more conventional clutch arrangement with which you're probably more familiar. The operating arm and release bearing are in the bell housing. As with the O2K, a code precisely identifies the gearbox and the engine to which it's matched. The Octavia is the first Skoda to be offered with an automatic transmission. The O1M is a 4-speed unit with electronic control. This means that the control unit is responsible for all the electrical and hydraulic functions. It also features an adaptive gear shift program, which adapts to the driver's most recent driving style. Various driving styles were used as the basis for the transmission's dynamic shift programs, ranging from ultra-economic to highly sporting. The control unit selects the appropriate program after learning the driver's style by monitoring throttle response, road speed, gearbox speed and engine revs. The transmission adapts quickly, thereby ensuring the best possible shift points for virtually all situations. To help smooth the gear shifts, the engine control unit receives a signal from the transmission control unit, instructing it to reduce engine torque when changing gear. The transmission also features torque converter lockup. Because the torque converter acts as a fluid flywheel, it normally has the disadvantage of converter slip with increasing engine speed. However, when the lockup clutch is activated, the converter is effectively bypassed, and the engine power is transmitted mechanically to the gearbox without any losses. The control unit decides when to operate the lockup clutch depending upon input signals. Note that on some models, an interlock mechanism, operated by a cable, prevents the ignition key from being removed unless the selector is in park. A solenoid device also prevents the selector from being moved from park or neutral until the brake pedal is depressed and the ignition is on. The Octavia's suspension provides a comfortable ride combined with precise and predictable handling. The front suspension is by McPherson struts and bottom wishbones with an anti-roll bar. The anti-roll bar is attached to the bottom wishbones by lightweight non-metallic links. The steering and suspension are supported by a subframe, which has pre-formed crash deformation points to direct the subframe downwards and backwards under the car in the event of a frontal collision. The whole assembly is attached to the body by large rubber mountings. To replace a McPherson strut, they must first be removed from the car together with the hub assemblies. The struts are attached to the hubs by a clamp and pinch bolt arrangement. A special tool, MP6-402, is needed to spread the hub slightly to release the strut. With the pinch bolt removed, the tool is inserted into the gap and then turned slightly to release the strut from the hub. Front camber angle cannot be adjusted, although it is possible to equalize any camber imbalance between either side wheels by slackening the mountings and moving the subframe across slightly. Incidentally, if you ever need to remove the front wheel bearings, then a special tool, MP6-416, will be required. The Octavia is fitted as standard with power-assisted, maintenance-free rack and pinion steering, which is adjustable for height and reach. The track rod ball joints have a different taper angle to simplify removal. A 6mm Allen key can be used to prevent the joint from turning while slackening or tightening the nut. Corrections to the track must always be adjusted equally on both sides. And note that because the rack and pinion has no centre mark, its central position can be determined only by counting the number of turns the wheel rotates from lock to lock. The Octavia has a trailing arm torsion beam rear axle with integral anti-roll bar and gas-filled shock absorbers. The road springs and shock absorbers are mounted separately. This increases interior space and helps to reduce road noise reaching the passenger compartment. The axle pivots on aluminium and bonded rubber bushes mounted at 25 degrees to the axle. The bushes, which are specially designed and must only be fitted in a specific direction, allow the rear axle to have passive steering. For example, when turning into a right-hand bend, the cornering forces will push against the left-hand side of the rear wheels. The special bushes allow these forces to move the axle slightly in the opposite direction to the front wheels. This helps to steer the rear of the car away from the inside of the bend to help it turn the corner. Of course, the amount the axle turns in this graphic has been exaggerated. In reality, it only moves a few millimeters. If the bushes need replacing, then a special tool, MP5-400, must be used to remove and install them. The rear wheel bearings are also different to previous Skoda models. They're a double ball race one-piece unit and are maintenance-free and are not adjustable. The bearings are an interference fit on the stub axle and the hub is secured by a self-locking nut. Removing a hub will destroy the bearings. To reassemble the hub onto the axle, you'll need the tool MP5-403. The Skoda Octavia will be available with ABS brakes, the basic principles of which were explained in video number 6. It's an ITT system like that of the Felicia, with a combined control unit and valve block. The brake circuits are diagonally split, with disc brakes at the front and drums at the rear. Rear disc brakes are standard on the higher engine output models. ABS incorporates electronic brake force distribution, or EBD for short. By analysing information from the wheel speed sensors, the system can detect rapidly when to reduce the braking effort to the rear axle. The system avoids the requirement for a rear brake pressure limiting valve. An addition to the ABS system will also be available. It's electronic differential lock, known as EDL for short. The system can detect, via the ABS wheel speed sensors, if a wheel starts to spin when accelerating away from rest, and then automatically apply the brake to the spinning wheel. This action, via the differential, transfers the drive to the other front wheel, and the vehicle is able to pull away smoothly. The system is inoperative at road speeds above approximately 25 kilometers per hour. Section 4. Electrics, Heating and Ventilation. The electrical system of the Octavia is arranged differently to previous models. Firstly, there's a small fuse box next to the battery. It houses 3 standard fuses and several fusible links. The fuses are for the ABS and the radiator fan's first speed, while the fusible links protect some of the larger current-carrying circuits. For example, this link protects the alternator circuit, and this one safeguards the main fuse box and relay carrier inside the car. On diesel models, the fusible link for the glow plug circuit can be found here too. Diesels also have 2 auxiliary relays close by to control the heater plugs of the coolant circuit. The car's main fuse box is at the end of the dashboard, and the various relays are in a separate carrier behind the lower part of the dash, immediately above the mini central electric station. It's also the point where most of the wiring harnesses join. There are also connection points at the bottom of both A-pillars, and another one under the bonnet. The engine control unit is also under the bonnet. It has 2 connectors. One handles voltage supply, etc., and the other includes the engine peripheral circuits, such as sensors and so on. You'll find the control unit for the automatic transmission in a similar place. The connection socket for the VAG 1552 is just here. To repair the wiring looms and/or their connections, a new repair kit, VAS 1978, is available. It contains most items you are likely to need to make a professional repair. To simplify repairs, each terminal has a length of flex, and the connectors are heat shrinkable to help guard against damp and corrosion. The kit even includes a heat gun. The new rotary-type light switch with integral panel light dimmer is very simple to remove. Make sure the switch is turned to off, and then push in the knob. Keeping it pressed, turn it to the right and pull out the switch. Another change concerns the X-relief circuit for the ignition switch. This is the circuit which turns off unnecessary loads when the starter is operated. The ignition switch has an extra set of contacts. These supply an X-relief relay, which in turn feeds many of the heavy current consumers, such as headlights, indicators and so on. The relay is energized only when the switch is in the ignition on position. When turning it to cranking, the contacts open and the relay is de-energized. This action turns off the heavy consumers, enabling more power to be available for starting. On releasing the key after starting, the contacts once again close and the circuits are reconnected. Removing the key, by the way, automatically switches off the supply to the radio and the warning buzzer. The Octavia has an all-new instrument panel with self-diagnosis, a service interval reminder, and a multifunction indicator is also fitted to some models. The multifunction indicator displays time, outside temperature, instantaneous fuel consumption, average fuel consumption, distance, average speed, and driving time. The service reminder in the odometer appears only on turning on the ignition when a service is due. Its calculations are based on time and distance. Do remember, though, that it must always be cancelled after a service, using the switches on the dash or with the 1552. Refer to the manual for details. Because the Octavia is technically different to previous models, new service schedules have been developed. Briefly, an inspection and oil change are required annually, while maintenance is necessary only every 30,000 kilometres. An additional oil change is required for cars which cover in excess of 15,000 kilometres per year. The engine immobiliser circuit, previously in a separate control unit, is now incorporated into the instrument panel. Although the immobiliser's basic function and operation remain the same, access to the self-diagnosis system has been changed slightly. Due to the combining of the immobiliser and the instrument panel, any self-diagnosis for either system must be directed via the instrument panel. The new address code for both the panel and the immobiliser is 17. Once entered, the main functions available are interrogate fault memory, including the instrument panel and the immobiliser, final control diagnosis, this checks the function of some of the instruments and warning lights, measuring value block for checking sensor signals and so on, coding, adaptation, and login. By entering different display group numbers within the measuring block function, numerous input signals ranging from road speed through to oil pressure can be monitored. Note that to increase the diagnosis capabilities, the 2-digit display group numbers have been replaced by 3-digit versions. There's more information on this subject in the applicable repair manual. Due to the combining of the immobiliser and instrument panel, it's essential, after exchanging a panel, for example, to match the ignition keys to the immobiliser using the login function. You'll also need to carry out the engine control unit adaptation, as failing to do so will prevent the engine from starting. Furthermore, the panel must be correctly coded to match the country and language, and the service interval reminder must be reset too. To avoid difficulties, always follow carefully the instructions in the manual. Removing the instrument panel is straightforward. Lower the steering column and remove the fascia's 3 torque screws. Release the lower clips. and the connector from the hazard switch and lift the fascia clear. The instrument panel itself is retained by 2 screws at the top. Don't forget to disconnect the wiring plugs, of course, and remember, if you're fitting a replacement panel, to note the mileage readings before you begin. To test the instrument panel's wiring, you'll require the latest adapter, VAG 1598/25. Depending upon whether the car has electric windows, 2 different versions of central locking system are fitted. Both versions have a control unit mounted behind the dash near the light switch, connected to individual door lock motors. The system can be operated from either front door or the boot. Locking the door with a single turn of the key activates the safe system, meaning that the doors cannot be opened from either outside or inside. The lock buttons are also prevented from being lifted. Alternatively, turning the key twice will not apply the safe system. In this mode, the doors can be opened from the inside, which is advisable if leaving occupants in the car. To simplify fault finding, the system has self-diagnosis. Vehicles fitted with central locking and electric windows use a comfort system. The system controls all the functions of the windows, central locking, electric mirrors, interior light, and illumination of the window switches, etc. The central control unit, behind the instrument panel, communicates with a local control unit in each door. The one in the driver's door incorporates the switches for the 4 windows and the master lock and unlock features. The other 3 local control units are integrated within the window motors. All the functions which relate to the doors, for example windows, door locks and mirrors, are communicated via 2 data cables known as the CAN network. The cables transmit coded signals to and from the different control units. The unique digital signals are recognized only by the components which are required to respond. If, for example, the lock button is pressed, then only the door lock solenoids will respond, and nothing else. Likewise, if a window switch is operated, then although the signals travel down the same 2 data cables, only the relevant window will respond. An acknowledgement signal is automatically sent back from the component, in this instance the window motor, to inform the network that the signal has been recognized and the operating state of the component. One of the advantages of this multiplex system is that by transmitting different digital signals along the CAN network, it's possible to increase the number of functions while at the same time reducing the amount of wiring. Incidentally, although the tailgate lock and several other items, such as the interior lights, are part of the comfort system, they are not communicated with by the multiplex system. Instead, they receive analog commands from the main control unit. And a couple of final points to note are that the windows can be automatically closed when locking the car, or opened when unlocking it. And of course, the system has extensive self-diagnosis facilities. The new heating and ventilation system includes a filter to remove a high proportion of industrial pollution, road dust and pollen from the air before it reaches the interior. It should be replaced every 30,000 kilometres. Prior to removing it, carefully clean away any leaves to avoid debris falling into the fan and the likely subsequent noises. Rotary controls regulate temperature and air distribution, while air recirculation, which prevents fumes entering the car when in traffic, is selected by a button. It's an electric motor which operates the recirculation flap. The recirculation function, by the way, won't work when the air is directed solely to the windscreen. The heating and ventilation unit is a complete assembly fitted behind the dashboard. To aid repair, though, it's been designed so that after removing a panel just above the passenger footwell, the fan can be withdrawn from below. You'll find details concerning the function of the various flaps in the self-study book. Manually regulated air conditioning is available as an option. The circuit is filled with R134A refrigerant and is largely unchanged from the Felicias. Section 5. Safety and Body. The Skoda Octavia's rigid body provides a high degree of active safety. Carefully designed crumple zones with side impact protection beams and foam inserts in the door panels all contribute to driver and passenger safety. Passive safety features include airbags and seatbelt pre-tensioners. This last item helps to restrain occupants by automatically tightening the seatbelts during a frontal collision. The pre-tensioners are of a new and compact design and utilize the Wankel rotary engine principle. Simplified, the seatbelt reel is connected by an epicyclic gear set to a triangular rotor. A mechanical crash sensor, not shown in this graphic, detects a frontal collision, and via a percussion device it detonates the first explosive charge. The expanding gases turn the rotor until the force of the explosion can trigger the second charge. This second detonation does two things. Firstly, via a small channel it moves the percussion device of the third charge to its ready position. And secondly, it turns the rotor further to tighten the seatbelt. If the rotor continues to turn further, because the belt has not been retracted sufficiently, the fourth charge is detonated. This pushes the rotor round even further, which in turn causes the third charge to be exploded. And remember, all this action takes place in under 20 milliseconds. Both driver and passenger airbags are fitted to the Octavia. Their basic function and operation is the same as that described in an earlier video, number 4, although the control unit has been further developed to include a new safety feature. In addition to energizing the airbags, a signal is sent to the central locking system to unlock the doors. And to aid fault finding, the airbag system includes self-diagnosis, which is interrogated using the 1552. The 1552 can also be used to disable the passenger's front airbag for customers who wish to use a rear-facing child seat. However, before attempting this operation, refer to the repair manual and consult the importer for additional information which may be specific to each country. The Octavia's interior door panels are moulded one-piece items with special foam inserts to help reduce injury in the event of a side impact. To remove a panel, it's the drivers we've chosen here. Firstly, prise out the door handle grip. And lift out the switch panel. Remove the 3 large screws from the door pull, followed by the screws from the 3 sides of the panel. You'll find another screw behind the door handle. The panel near the mirror must be removed along with the lock button. The door panel can then be released by lifting it firmly. Before refitting the panel, take care to refit the interior handle's cable correctly. On cars with manual windows, the handles are simple to remove. Sliding the collar releases it, and it's equally simple to refit. In its class, the Skoda Octavia can compete with the best. And in many ways, its high levels of equipment, safety and build quality put it ahead of the competition. For all involved with the Skoda product, particularly the technicians, it's an exciting time with lots to learn. It's impossible to learn everything straight away, but hopefully viewing this video will have helped you to get started. And remember, every one of us has an equally important role in making the Skoda Octavia a resounding success.